In this video, we are going to introduce the concept of congruent triangles. Congruent triangles referring to two triangles which have three equal sides and three equal angles. For example, in this triangle ABC and triangle XYEZ, you will see that AB is equal to XY, and then BC equal to YEZ, and AC is equal to XEZ. And for angles, angle A is equal to angle X, angle B equal to angle Y, and angle C equal to angle EZ. To talk about the congruent relations between the between the triangles, we make use of the symbol like this one to relate them. And then, so let's see how we can use the symbol. First of all, we have the first triangle called triangle ABC. This one is congruent to a triangle. So shall we write XYEZ, YXEZ, or EZXY? There is a very rigid requirement of the order of the letters when we write congruent triangles. We should match the equal angles together. For example, angle A is matching to angle X, so that's why the first letter matching to A should be at X. So we have triangle X blah blah. And afterward, angle B is matching to angle Y, so that's why the second letter B should be matching to the angle Y. Finally, we still have the last letter, so which is EZ. So in this question, just by coincidence, triangle ABC is congruent to triangle XYEZ. Next, let's try two more questions to see whether you can match the angles or match the letters properly. So for part A, and now you have triangle ABC is congruent to, so let's look at angle A is matching to Y, so the first letter should be Y, followed by angle B is matching to angle X, so second letter to be X. So the last letter, you know to match, but there's only one letter left behind, which is EZ. So finally, you have triangle ABC is congruent to triangle YXEZ. Similarly, next question, LMN. So luckily, we don't know L is matching to another angle. So in order to start with, so I prefer to look at angle M, which is a 90 degree. M is matching to R, M is the second letter, so that's why the triangle should be having R in the middle. Whereas angle N is matching to angle P, so that's why N, the third letter, should match with P at last. Finally, we still have the last letter, which is Q. So the question or the answer should be triangle LMN is congruent to triangle QRP. So I would like to put your attention to, besides the angles are matching to each other, actually the sides are matching as well. What do I mean? For example, can you see that in this triangle, length AB, which are the first two letters, should match to side XY, which is the first two letters. Similarly, for example, you can look at length AC, which is the third and the first letter, should match with YEZ, which is the first and the third letter. So as a result, by looking at the congruent triangles, then you can see or read the letters to judge which angles are the same as well as which sides are the same. Let's look at one more. For example, if I want to know MN, the length, is equal to which side in another triangle, so we can look at the last two letters, which is called RP, and these two sides, they are the same to each other. Next, let's take a look on this question to see how congruent triangles can help us to find the unknowns. At first, the question tells us that the triangles are congruent to each other. And now we have three unknowns, including P, N, and M over there. To start with, normally I prefer to look at angles because somehow to me it's easier. So for example, 116 appears in the first triangle, which is indicated in the third letter. So according to congruent triangles, angle R will be equal to angle Y. So that's why at first we have 4P equal to 116 degree. So for this, we have to write a reason and explaining that we are going to check, or we have checked the relations between congruent triangles. And this reason is called corresponding angles, congruent triangles. So after that, you can do it by calculator or do it mentally. So you have 4 2 is 8, and then 4 9 is 36, and getting P to be 29. Quite easy, right? Afterward, for lengths, so it requires you a little bit more technique. Let's say we start with 3n, that means the line QR. QR in the question, so you will see that it comes from the second and the third letter. According to congruent triangles is equal to xy, which are also in the second and the third position. So as a result, 3n will be equal to xy, which means the 6 meter in the second triangle. And the reason? How about you make a guess? Previously, we are talking about corresponding angles. Now we are matching the lengths or the sides, so that's why it's called corresponding sides, congruent triangles. And as a result, n is 2 can be obtained quite easily. The last one hopefully is not a really challenge to you, because finally we look at the line PQ, which is the first two letters. It matches to ZX, which is 28 in the figure. So as a result, xm minus 4, now I'm matching it to 28, which is based on the same reason called corresponding sides, congruent triangles. It gives you xm to be 32, and finally m is a 4. After knowing the features of congruent triangles, now it comes to how we can prove triangles are congruent. As mentioned before, the definition of congruent triangles means that they have 3 pairs of corresponding sides and also 3 pairs of corresponding angles which are equal. So there are totally 6 conditions or 6 things you're going to check. Is there any way to shorten it or simplify it? Yes, in math we have totally 5 conditions to talk about congruent triangles, including the first one SSS, SAS, ASA, AAS, and RHS. So it's so troublesome, right? But beforehand, so make sure that you should know the meaning of each letter. S, it stands for side. So that's why SSS means that you are talking about the 3 sides are equal to each other, as indicated in the figure. Whereas A, which is talking about angle. So that's why in number 2, you can see that you have 2 sides which are the same, and A, the same as well. But please note the position of A will be important in writing the reason. For example, SAS stands for you have two equal pair of sides, and A in the middle means that the angle A, now I'm marking in yellow, they are equal to each other and they are located between the 2 sides. Next, we come to the next reason called ASA. You will see that the 2 blue angles are located on 2 sides. The meaning of S in the middle means that the S should be right between the 2 equal angles we are considering. Whereas the fourth reason, AAS, means you also have 2 pair of equal angles, but now S is outside means that S is no longer between the 2 angles. So many students got confused about ASA and ASA. So you pay attention to the position of S if it is between A and A. So in the figure, S, the side should be between A and A as well. The last one is pretty hard because you have 2 new letters, including R stand for right angle, or simply that means 90 degree. As indicated in the figure, you have 90 and 90 over there. Whereas for H, it is a special side in right angle triangle, which is called hypotenuse. So it is the longest side of a right angle triangle, and also it is opposite to the 90 degree. Once in the proof of congruent triangles that you are considering a right angle, 90 degree, as well as a hypotenuse, then the reason very likely to be RHS. Finally, the S, so as indicated, it can be chosen as any one side, like this one, or you may have another figure like this. For example, you consider 2 right angle triangle, so 90 degree first, equal hypotenuse. The A you can choose to be this one. In this case, it is also called RHS. Next, we're going to use 5 examples to demonstrate the ideas of using the 5 different conditions to say the triangles are congruent. It's a little bit tedious, but it's necessary to learn it because we want to write a very clear and rigid proof. So let's start from number 1. This one is a very obvious one to see 3 equal sides because first of all you have 5 cm, next you have 3 cm, and lastly you have 7 cm. So let's start. In number 1, we say AB is equal to RQ, which is equal to 5. In order to write a remark, we say it is a given condition, or simply we say give it. Next, we write down AC equal to PQ equal to 3. Again, it is given in the question. And finally, we have BC equal to PR equal to 7, which is also a given condition. Afterward, according to the condition of congruent triangles, and you will see the triangles ABC is congruent to triangle. Wait, should we write PQR, PRQ, or whatever? So that makes something harder as follows. So we need to go back to our original concept of matching the angles or sides to write it. But luckily, we don't have any angles. So that's why we have a trick. Can you see that angle A is right between 5 and 3? Whereas between 5 and 3 in another triangle should be the Q. So that's why A, which is the first letter, should match with the first letter in the second triangle. Can you grasp the idea? If yes, so let's try one more. Angle B, I mark it as red, is between 5 and 7. So in another triangle, you can see R will be between 5 and 7. So that's why the second letter will be R. Finally, you see that the triangle, we shouldn't write PQR, but it should be named as QRP if you want to present it as something about congruent triangles. And lastly, we have the condition. We say it is side, side to side, or simply SSS. So this is the proof of talking about the triangles are congruent to each other because of SSS. Next, number 2, and now you can see it's a totally different condition because this time we have angle 65 and then 32, finally a length of 4.5, 4.5, which is right between the two equal angles. So let's start the proof. We have angle R is equal to angle X equal to 65 degree, and we say it is a given condition. Angle Q equal to angle Y equal to 32 degree, again it is a given condition. Oh, I should change the color, but it's alright. Finally, we have RQ equal to YX equal to 4.5, again it's a given condition. Finally, you can see we have fulfilled the conditions of ASA in proving congruent triangles. So as a result, now triangle PQR is congruent to, once again, we have to write or match the letters very carefully. So let's start from yellow. Yellow is angle Q, matching to angle Y. Second letter Q, so it should be second letter Y. Next, we come to the blue angle, 65, which is a R, matching to X, so that's why X is the last letter. And finally, you just fill up the last letter, which is EZ, so that's why the reason is called ASA. Next, let's go ahead to the third example. And now you have AB equal to IJ, first length. So AB equal to IJ, so equal to 2, which is given. And then next in red, you have AC equal to IK equal to 3.9, which is also given. And finally, which is special is, well, you can see there is a right angle triangle there, and so that's why we have to write angle B equal to angle J equal to 90 degree, which is also given. So when you see a 90 degree, there are normally basically two situations. It may be RHS because of the right angle, or it may be a SAS. So to judge to which reason we are going to apply in the question, we're trying to see whether we have an H. What do you mean by H? So let's highlight as follows. When you have a 90 degree, the side opposite to it will be called hypotenuse. For example, the first triangle is called AC. Similarly, opposite to 90 degree at J is the length or the side called IK. So now in the question, you can see the edge exists, or the edge is considered in the question. So that's why you have a R, that means 90 degree, you have a H, hypotenuse, and the 2 cm, so stand for the S. So as a result, the question or the answer of this one will be triangle ABC is congruent to triangle blah blah blah. Also, we will fill up it afterward, but anyway, it will be the reason called RHS. After this example, in example 4, we will give you another situation that the question is not about RHS. Okay, so now let's see. We normally start with the angle. Angle B is angle J, second letter, so J should be put in the middle. And then now it comes to a little bit troublesome. How about I use green to mark the angle? Between 2 and 3.9 is angle A, first letter. Between 2 and 3.9 should be angle I, so I should be put in the at first. Finally, so with the triangle should be IJK in the first question. Whereas in the second question, I call question number 4. And now you have, okay, let's start, 3.5, 3.5. That means EF equal to IJ equal to 4 cm, so which is called given once again. And then in green, 6 cm, 6 cm, you have FG equal to IK equal to 6 cm, which is also a given condition. Finally, we have F and I. Angle F and angle I will be 90 degree, which is also a given condition. So that's why we have 3 conditions in the question. But now, according to the study about let's write here clearly. So shall I use RHS or should I use SAS, which is determined by whether the hypotenuse is considered in the question. And now the hypotenuse should be called EG and JK, but sorry that we did not conclude or did not consider it in the proof. So that's why you can see finally the question or the what should I say, the answer should be is a S. It's not very clear. Wait, it should be SAS here, SAS here only. So finally is angle EFG congruent to. How about this time I pause for 10 seconds for you to choose the suitable letters for IJK in order to conclude or finalize the question saying that the triangles are congruent because of SAS. Let's try it now. Alright, so finally F should be matching to I, so that's why I should be at the middle. And then 3.5 is called FE, so J should be at first. My meaning is EF is 3.5, IJ is 3.5, so J should be the first letter. So finally, the last letter will be K, JIK. Here comes the final example, the 5th one, talking about the last reason. Do you remember which one is missing? So let's have a recall. On there are 5 conditions called SSS, SAS, ASA, AAS, and also RHS. And then the last one should be talking about AAS, which is missing in the previous 4 examples. Now we come to the work. First of all, you have angle C is your angle D, which is 47. So I mark it in blue here, given information. 75, 75, angle B equal to angle E, equal 75 degree, which is also a given reason. That's already not reason, information. Finally, we have A and AB and EF equal to 8 cm, so which is also given. Finally, you will see that this one we don't call it ASA because now the 2 angles, for example, angle B, angle C, and now the last side 8 cm is outside or not between them. So that's why for this reason we will call it triangle ABC is congruent to another triangle because of AAS, to emphasize that the S is not between the 2 angles. Finally, you just check the letter. C should be matching to D, which is the last letter. Yellow 75 is angle B, matching to second letter, which is E. And lastly, of course, we have the last letter, D, E, F, and complete the question. So after these 5 examples, hopefully you have grasped the basic ideas of using different conditions to prove that the triangles are congruent. After all these examples, there may be a question in your mind. Why do these reasons work to say the triangles are congruent? It is a very good question, but yet it's a very difficult to explain. So I try to use different ways to explain parts or some of the reasons as follow. So first of all, SSS would be talking about you have 3 equal sides. If you have some rods or toothpick at home, then you can prepare yourselves. For example, you prepare one is 5 cm, one is like 12 cm, one is like 13 cm. So you can try to make different triangles, but yet the triangle should be in this shape. So it's like 5, 12, and 13, and then it may be like 13 here, 12 here, and 5 here, and then anyway like you can have different orientation like 5 here, 12 here, and 5, and then lastly 13 here. So but whatever or wherever you put the sticks, you will finally see that the triangles are actually the same. So it's just difference of like by reflection or by turning its orientation, etc. So it may be somehow telling you why SSS should be talking about the triangles which are congruent to each other. And then for SAS can be understood in this way. So we can have examples like, how about if you think like it's 4 and 6 here with a 30 degree. So even though you turn into other direction, for example like 4 here, 6 here, 4 and 6 and 30 degree, or even like maybe maybe like this one, 6 and 4, 6 here, 4 here, and 30 degree here. Can you find that no matter where you put the SAS, lastly there are only one way for you to close or to make the triangle, at the red line, at the red line, and at the red line. But yet the triangles are the same because the SAS restrict the frame or make a frame for the triangle already. Well, for the last one I'm going to explain in this video, let's say how about look at ASA. ASA will be a bit difficult to draw. For example, like it's 4 cm here, then you think of it is 30 degree, maybe this is 40 degree. So you have different ways to put it. For example, like 4 here, so this time you have 40 degree, you have 30 degree here, or you can turn it upside down like 4 here, 30 degree here, and then 40 degree here. So the dot line means that you go to extend or try to draw a line in that direction because the angle 30, 40 are restricted for you. But by the way, now I'm going to use so can I have another color? Let's see, maybe purple. Now can you see that if you draw a line along the 30 degree, draw a line along the line 40 degree, there's only one triangle to make. Similarly, 40 here, 30 here, one line to make. 30 here, 40 here, oh sorry, it's out of bound. But anyway, when you extend the lines along the angles 30 and 40, you see you have only one way to draw the triangle. What do you mean by one way? It means that you can only draw one kind of triangle. So it's like I'm drawing 3 triangles, but indeed they are equal to each other. So they are only different by like reflection or like turning the orientation. So now it's almost to the end of talking about congruent triangles. But yet, you will find that it's a very difficult chapter because it can combine with other different proofs or different references on geometry. For example, like this one. The question itself is asking you to prove triangle ABC and ADC are congruent to each other. So as a result, you need to search for some conditions. So for example, like the red one first, you have 2 equal angles at point A. So that's why at first we can write angle A. No, but we have to write precisely. It's called DAC, and also another angle called BAC equal to each other, which is given. But then you will see that you cannot use the two equal angles as C respectively, because they are outside the triangle. So that's why you have to turn it or move it inside the triangle in order to apply that. How can we do it? So this is the trick as follows. And now, because the angles are given to be the same, so you can make use of a letter A for your convenience to present it. Afterward, can you see that the two angles are equal to each other? Yes, very good. It's something about adjacent angles on straight line. So as a result, you have to write as angle DCA will be not A, is 180 degree minus A, because of the reason called adjacent angles on straight line. Similarly, you can also say angle BCA equal to 180 degree minus A, called adjacent angles on straight line. As a result, now you can conclude that the two angles DCA and also BCA are equal to each other. So this is some extension or like harder question after you have learned the concept of congruent triangles. It's now integrated with different reasons like adjacent angles on straight line you have learned in the previous video or any other chapter, and then in order to prove the triangles itself. Finally, there is also a funny reason on proving the congruent triangles, which is sometimes we make use of the same length or same side, like this one, AC is equal to AC. But we don't say it's given, but we more precisely say that the side themselves, they are common. That means we are using the same side, so we write the reason called common side. And finally, you can see the red line is between yellow angle and the green angle, and so the reason now will be saying that triangle ABC is congruent to triangle blah 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 because of A as A. Once again, takes 10 seconds or maybe at most 20 seconds to fill up the letters appropriately. Look at the angles first to see or match the letters, so see whether you can fill up the 3 blanks in the second triangle. Okay, so let's see whether you can do it. A should be matching to A, so first letter is A here, so it's about the yellow angles. C in green should be matching to B. Should be matching to C as well. And finally, the last letter should be D left behind. So this is triangle ABC and triangle ADC. Oops, sorry, actually I played you. Because in the question, the congruent triangles ABC and ADC is already given. So indeed, in this question, you need not to match the letters, but you can just copy the answer. So sometimes if you are very alert about the question, or you are smart enough, you won't be played by the teacher. Finally, so let's take this question as the end of this video. And you finally learn the whole chapter. Is it very fast? So this question is combined or integrating with the concept of parallel lines as well. But anyway, the question itself is about congruent triangles. So let's see anything can be used. Well, the first trouble is you don't have any equal angles at first. And moreover, when you talk about AE is equal to FD, none of them is a side or length of the triangle. You can say AE is only part of EF, and then DF is part of DE as well. So that's why we need some tricks in doing or working on it as well. So by the way, let's see how the parallel lines will help. For example, when you see AB is parallel to CE, now I color in yellow, and you will see that you can find corresponding angles here. So that's why at first you can see the angle A and angle E, they are equal to each other. So we have angle A equal to, sorry, for angle E we have to write very precisely, calling it to be CED, and we've matched the first letter A and E. So this one is not given, nor corresponding angles, but we say this is corresponding angles, AB parallel to CE. Next, we go to look at another pair of parallel lines, which is BF and FD, with two arrows over there. So along these parallel lines, you can see that we can also seek for corresponding angles, which are located at F and D respectively. So as a result, by using the same method, we can say angle AFB equal to angle D, again because of corresponding angles, but this time is BF parallel to CD. So we successfully find two ends in the proof of congruent triangles. Now at last, we try to see how we are going to find like one S to use it. Because once you have 2A, so there are two choices. Either you look at ASA or you look at AAS. Both of them help us to solve the problem of congruent triangles. And now I will look at the information I haven't been used yet. We have AE is equal to FB as indicated in the question. So AE is not part of the triangle, so that's why we try to look at some longer side. For example, we look at AF. Can you see that AF composes of AE and EF? So that means you need to add the short piece EF, which is in the middle. Similarly, in order to use FD, you need to look at ED. Again, it is also the side AD add up to EF. So the trick in this question is, we are not just looking at AE, FD, which are given in the figure, but we need to look at EF at the same time. So we say, because AE is equal to FD, which is given, and then AF now is equal to AE plus EF, and also now we have DE equal to DF plus FE. So as a result, now we can conclude that AF is equal to ED in the figure. And finally, you will see that the S is between the two angles, and that's why triangle ABF will be congruent to triangle ECD because of the reason called ASA finally.